Hello everyone, welcome back to Engineering 3D CAD tutorials. Myself Ravi Kirti, having 15 years of experience in industrial design. So I've given an introductory part in the last video. So let us move to the introduction to manufacturing technology. As per my knowledge should flow freely from one person to another. The transformation of knowledge should not involve any price, or it should not be sold to anybody. So my concept is that one, how much I know I will try to teach, or I want to convey or transfer to the next person. That is my intention. So let us move to the introduction to manufacturing technology. So let us discuss what is manufacturing. So it's a very, in simple words, we can define in such a way that the process of transforming raw material into a finished goods. So it's changing one form to another form. This is very simple. Suppose you are changing preparing a food from raw material to if you're taking a raw rice, you are preparing a rice, then that's a required product. It's a boiled rice is the required product. So in similar way, so you can see manufacturing, or you can say as a production. Those two are like very nearby words. So moving forward, so manufacturing technology encompasses a broad range of tools, techniques and process to transform raw materials into finished products. As I told earlier, you are using so many tools. So when you are preparing any kind of dishes, you will use a lot of utensils and a burning stove or a burner as a tool, or you are using a spoon, or to avoid when it's heat you can't touch in your bare hands. So when it's coming to this one, we are using a lot of tools, techniques. So some amount of techniques are involved, and process to transform. I told the process. So tools I told. So what is the technique? The technique is that how much time it has to be cooked. So if you cook more, the taste will become different. So it's for understanding. So when you are coming to a blacksmith is heating an iron rod for a certain period of time until it get red hot condition, then he will hit with a hammer. He will select the proper tool. Suppose the diameter of the rod, heated rod is small, then he will use the small hammer. If it's a big, then he will use the bigger hammer. The size will differ. So the techniques required. So for at what period, what type of tools to be used, for how many amount of time, how much amount of time. Suppose it has to be hit by 4 times, 5 times, 10 times, 100 times to get the desired shape. So there is a technique. So process. So historical context, if you take the history, the evolved from the simple method used by the earlier humans, such as shaping stone tools. So previously, suppose for hunting purpose and everything, humans are using lot of tools. So those are made by the suppose if you take a sharp kind of this one to divide. So or so to make this sharp, they may use different type of techniques to make a sharp edges. So it may be a very simple one, or it may be some 3D form. So, and if sometimes they may use some type of axe kind of thing. So these are the things we can see. Okay, so moving forward, so this is the historical context. That means when the human evolution form, so simple stones, simple wooden tools they are used, stone tools they are used, as hand tools they have started using that one. So modern advancements, suppose current state features cutting edge automation and digital platformation. Significance, key role in development of civilization, driving economics and influencing culture. So if you see every stage, in the older stage they have started using the stone or a wood which is made out of wood. So later they have started using the metals. The thing is that to use that as a cutting tool or an equipment, it should have a sufficient strength. So where it will come the mechanical properties or metallurgy or material technology, you can call it as. So as we are going advanced, so advanced in the sense what? We reform the process, we reform the design, we reform the shape of the tool. So that's how it has given a new look to this one. So nowadays you are in a cutting edge automation and digital platform. Later, because initially we don't have the industrial revolution, so we don't know how to manufacture. Even a goods is produced, a raw material produced in a country A, the entire raw material will carry out to the country B, and there they will do the process of that one. Suppose if you take it, cotton as a raw material, they will take it over there and they will process that and they will make it into thread and they will move that to the next country where they will make it into cloths, and then they will make mark with certain brand and they will send it to the where they have obtained the raw materials. So this is how happened in the initial stages. In the later stages, what happened, and as the technology advancements, it's a reformation and it's a repetitive modification for the improvement of the process. So what they're telling, the civilization driving economics and influencing culture. So as a civilization, as we civilized, I told, the advancement is the civilization, the driving economies. So driving economies means as the population is more, the demand is more, you have to produce more and more and more and more and more. Then only you can fulfill the needs of the society. So to address the issue, you have to production has to be done in a faster way, so then only economically they can sustain. So if you produce suppose example, if you produce a single component or a single product by spending a single day, like an 8 hours of working hours, then the cost of the product will be higher. And in 8 hours, if you produce 10,000 components, suppose the machine cost and the labor cost is you can divide it for the 300 or 10,000 components what you produce. Otherwise it will be for one component it will be huge. So regarding for the driving of the economy also, the tools are very very important, the advancement also very very important. Moving forward, pre-industrial era of manufacturing. Pre-industrial era. So if you see in the pre-industrial era, the entire thing is depending on labors. The entire thing is depending on labors, and it requires high skilled. High skilled means who knows he can perform the duties and he can produce the things. Otherwise he can't produce the things. So that's how the hours of days are crafting a single item. As I told earlier, if a person is spending more hours to produce a single component, the cost of the product will be at the higher end, and you can serve for a certain amount of society, not in a full-fledged. So tools and techniques: simple manual process, limited production capabilities, techniques inherited across generations. See what happened due to these. A person who is an external, who is not belongs to a community, or who is not belongs to an that religion or region, he can't learn that one, because it needs a lot of attention, practice, and he has to spend a lot of hours with the man who knows very well, who is technically good at it. So that's why what happened, it will coming through a father grandfather to father to a kid, like that. In that way, it's like a generation based skills have developed, because before pre-industrialization, because the technology means a skilled person. A technology means a skilled person who knows he can perform. So that's how the tech skills are not distributed in an equal manner, and the world is suffering from that skills. So moving forward, if you take the example, as I told earlier also, blacksmith used to fire hammers and enhance a shape of metals, potters more clay and using. So in these cases, if you see in the previous era, a person who is a pottery making person, his kid will know how to do certain designs, and he is very versatile, because his father, because of the observation, every day he will observe and he will learn, he will make a lot of mistakes, correct himself. So even a blacksmith also giving a shape to a sword or to any equipment, his son will understand in a better way. So then these kind of skills are limited to a certain amount of people. So moving forward, the Industrial Revolution plays a vital role in the advancement of the human society. So if you see 18th century, we can call it as an Industrial Revolution, where the steam engines came for S1, and also they have started converting the energy from one state to another state. So here by using steam engine, they have started by using the locomotive engine, they started moving that one. So in the similar way, if you see the introduction to steam engine, what happened? A steam will make movement. So the excess amount of action, what is a steam which will be pressurized, and cylinders will be moved, the piston will be moved. So how the steam engine works? Invention of a cotton gin. So I told earlier, a man who knows how to make a thread, he can produce the cotton. Previously, before the Industrial Revolution, lot of countries don't have cloth to wear. So you understand the importance of Industrial Revolution. So later the sewing machines came, how to convert cotton to a thread to a cloth. So all these things, advancements we can call it as now, even though it is not an advancement, fulfilling the basic necessities of the society happened. That one. Advancement of mechanized textile production, other technologies breakthrough. So if you see the cycle or the motorcycles that started coming inside, so scooters, bikes, you can call it as so automobiles coming to picture. So because of this advancement in the textile industry, they are able to produce a sufficient amount of cloths to wear. Now we are having a sufficient amount of cloth, but previously they don't know how to stitch that one, how to make even a certain areas. They will wear half of the body and they will not cover the half body. So that's why the industrial revolution plays a vital role in the manufacturing sector. That means converting one form to another form to the required application. The impact of manufacturing: onset of the large scale of manufacturing, significant boost to production in capacities. I told earlier, because of this large scale manufacturing, the cost has been reduced. Otherwise the cost will remain at the higher end, and the poor, low class and the middle class person may not able to offer to get the goods what are required to lead the comfortable life. Okay, the societal and economic transformation. See, once the major shift in economics, I told earlier, the trade, what we are doing, suppose if you are selling a single shirt, a single pant, or a single by spending an entire 8 hours on that one, that may give you the little bit amount of higher cost, but not if you produce 10,000 components or 10,000 shirts for within 8 hours. So that is unimaginable, and we can't compare all between these two. So other than that, if you see urbanization of the population, birth of the factories based mass production concept. So I told earlier, see, urbanization of a population. See, previously where the water is available, there the civilizations are started, and for agriculture, depending on the agriculture to generate the food products, they have started remaining in the river banks, and they have started agriculture as a major source of food. So later on, once the urbanization started, that means the industrialization started, the labors required, they have started moving from one place to another place. So the urbanization happened. That means the people who are staying in the rural areas, they have moved to urban areas, because when they are staying in the rural areas, they are not skilled laborers. Once they have moved to urban areas, the skills are enhanced, developed, and their next generations is completely different from their generations. So this thing, urbanization started happening, the economical growth happened, the way of thinking, way of learning the things, understanding the things, and these things are started. So birth of the factory based mass production concepts. I told earlier, if a person is good at certain skills, he can produce the certain amount of products. But once this has been factory based mass production started, the skills are multiplied, and in certain cases the semi skilled people can work and they can produce the products. So this has been started. So moving forward, primary categories of manufacturing process. If you see primary categories, what are the primary categories we are using in manufacturing? So when it's coming to mechanical related, so we can give it as an so forming process. See, deformation of material to achieve desired shape without adding or removing a material. So as I told earlier, a blacksmith who is giving a shape to a sword, what he will do, he will start heating to the certain amount of temperature, and he will use the hammering that one, and he will bring to that one. This is called as a forming process. That means there is no removal of material, it's a transforming of shape from one to another shape. So example, see, shaping under a compressive forces. Suppose if you see any wheels which are manufactured, railway wheels, they are made by the compressive forces, because it will have an very compressed, that means a good strength in the product. So casting, pouring of a molten material into mold. Suppose if you take you can see if you want to produce an alloy wheel for the car or for this bike or scooter, they will start pouring the molten material which is in a liquid state. They will pour into this one, it will get inside the cavity or the where the space is there, and you can produce the shape what you have previously made inside the mold you will get. So this is the forming process. You can this is a forming process, and this you can consider as a casting, where these two are different. Actually forging is different, but here also you are just pouring the liquid to get the desired solid state. Subtractive process, so huge manufacturing industry process are depending on this one, subtractive process. Suppose you want to produce any teacup. Suppose if you want to produce a teacup or any, if you consider this is a cup you want to produce, so what you will do, you will take this size of a raw material, and you will start removing the material here. You can by using a turning, facing this side also facing here, taper turning you can do. Later you can do boring, or you can consider this as a first, facing is the first, and this one is the second one, and this is the third one. And if the your raw material is lengthier one, you just cut off here, you will get the product in this way. So if you consider to produce only this amount of material, you have wasted nearly this area as well as this area. So this is a very time taking, and it also it will make a lot of wastage. I can say, put it in this way, the amount of raw material and the amount of the final goods, take the ratio between, so the time taken to remove the excess material will be more in the maximum cases. So what they will do in certain cases, suppose if they want to produce this type of this one, actually what they will do, suppose this is so a preformed will be molded, or casted, and they will just clean this surface little bit, this surface little bit, this surface little bit. So in this case they can avoid, they can make some fixtures to give the final of this one. Otherwise sometimes if they directly go for casting, they can eliminate this one. But in the major cases, the removal of material will be more, like a milling, drilling, turning, shaping. So surface grinding, jig boring, jig grinding, so EDM you can take. So it's a removal of material. So in the when you come to removal of material, we are having a basic machining and advanced machining. So we will come into this thing in a later stages. So examples: removing of a metal from the rotating cutters, milling cutters, where it will rotate and it will remove, multi-point cutters. So drilling, so introducing holes into a workpiece, so where you are drilling, making a hole in a component. So those are the different of things are there. So moving forward, adhesive process, I told advanced manufacturing. In advanced manufacturing we will go to adhesive process, where you are adding, instead of removing the material from the base raw material, you will add layer by layer by layer. If you see the 3D printing technology, you can understand different layer by layer object, and 3D printing as the prime example. Metal, plastic, metals, and for the for integrators. So in this one, actually, in 3D printing, the metals, plastics, and composites they will print. So even aerospace industry is running behind this one to reduce the cost of the production of the components. Joining process, if you see, the joining process means welding, soldering. So these are all coming under joining process. So welding, fusion of metal using heat. By the application of heat, you will melt and join. Sometimes rotating two similar profiles and just merge due to the friction generated heat. Heat weld will going to happen. So welding, fusion metals using heat, as I told, those two metals will heat and they will fuse. So soldering, join of metal by the melting of a filler metal. The addition material will be used, and glue will be adhesive materials also used. So when you are using different type of metals, you want to add together or merge together, or you want to give the shape together. Suppose in certain cases, for example, you are using an object or a metal which will which can't resist higher temperature, a coating or additional cladding will be done for the component. So there you can use the additional material. So moving forward, so the digital shift, automation and computerization in World War. See, actually, if we are coming to the shift, dramatic shift after World War II, it's an unbelievable. Why unbelievable means the once the CAD/CAM introduced, it played in a very vital role. If you see the introduction to computers, so introduction of computer, development of CNC machines, higher precision components, software's impact on manufacturing. So as I told earlier, when we are using previous machines, those are conventional machines, the tolerances and the deviations from the given drawing will be always differ. So component A produced on the same machine, component B may have a different dimensions. That means even though it's negligible, but they can't produce the same or the similar one, where some of the dimensions will be deviated from the main. But once the CNC came, the programming by using different languages, the coding has what they made, the repeatability has been increased. The component produced first component, 100 component, 1000 component, 10,000, 1 lakh, 2 lakh, 1 crore, the dimensions remain same. Yes, of course we have to consider certain amount of things like a tool wear out, cooling, and also certain machine vibrations. So those are the other things we will study in the later stages. But the production has been dramatically increased without reducing the quality of the component. Rise of CAD/CAM software, digital drafting, intro designs, or conventional design manufacturing. See, suppose I will tell you one thing. Previously now also, before 10 years or 8 years, we are giving 2D drawings to the vendor to produce the components. Nowadays it's not required. If you are able to give that in a IGS or a step file, or it's a parasolid form, they can just program they can just import to the software and they can program. Previously what they are doing, they are generating the 3D models by using the dimensions. So nowadays that kind of that much skills are not required. As the advanced technology become advancing, the skilled, semi-skilled persons can work very well to produce the good products. So modern trends in manufacturing technology nowadays, we are calling it smart manufacturing and industrial 4.0, integration of IoT, Internet of Things, and advanced analytics, evolution of smart factories, cyber physical system, and human enterprise enhance enforcement productivity. See, what is industry 4.0 or what is smart manufacturing? So it's a very important to understand at this current situation where the AI ruling the entire world. And what is industrial 4.0? Suppose it is like an integration of one system to another system by using the internet. Let me give an example. Suppose I want an iPhone or an phone, so where I can customize that one, where I want both the touch screen and as well as the keypad. So the person, the company A will provide a list of designs you can use in a combination. Once I have placed the order, in the factory, the robot or the assigned machine will take the as per the design, it will analyze what material to be taken, and it will machine everything, and it will provide a QC by using the probes like a CMM measurement, coordinate measuring machines, and scanner machines, and it will make sure the component is free from defects and it is accurate as per the given dimension. When it has been done, it will forward to the assembly line. The robots will assemble the entire components to the to the model, and later it will test. Another robot will test, and it will record the test data, how it's performing well, all buttons are working, is the screen is working fine. It will generate the computerized that one, and it will pack that one until move to the shipping company, where the shipping company is having a truck. There is no driverless truck, and it will bring that one. The drone will pick up and it will drop in front of your home. That much of a bigger, it's like an end to end, there is no human interaction. That much big planning or an thought is going on. So this is an industrial 4.0 where they want to reduce all human interactions, eliminate the errors, where they're giving the directly signals are communicating through the internet, and they're giving the all instructions to machines through internet. There is no coding or anything. So sustainability, emphasis of a green manufacturing, minimizing of the waste and energy use, growing popularity of this circular economy model. See, sustainability, when it's coming to sustainability, we have to understand in such a way when the human beings are thinking or understanding how to utilize the 100% of material instead of wasting something. If you go for the press tool, or if you are going for the machining, or if you go for the casting, how to utilize. Suppose if you go to press tool, we are producing an utilization under certain consideration. By using utilization factor, strip layout will be developed. So where we can consume the maximum, suppose the 100 kilo material, if you bring as an raw material, at least let us use till 96% of the materials will be transferred as a component instead of wasting as a scrap or an left out material. So that's how, what you see is if you use you utilize the maximum amount of material, then the recycling is always then the left out material will be sent to the scrap yard and they will melt again, and they have to do so. This will what is where the transformation of material from one state to another state, where there some amount of energy is required, it's a loss to the nature. The additive manufacturing, emerging 3D printing technology revolution, aerospace, medical and more enables to customize the production and reduce the waste. As I told earlier, the advanced as an advanced manufacturing technology, so many aerospace, medical, when someone lost some bone cracked, or they want to replace any joint, they will go for the 3D printing. Even all medical dentists are using to produce the teeth by taking the mold of the copy of that one. So this is an advanced manufacturing technology today we are using in the current stages. So when we are coming to challenges and the future of manufacturing, very important. So as I told earlier, initially with a stone they started using the producing the required obtaining required components or the goods. So now we are in a situation we are very much advanced. We are using a laser technology, 3D printing technology, so lot of things. Even human organs can be 3D printed, that much advanced we are, but certain challenges are still remain. So skill gaps needs to train the work in evolving technology. See, as I told earlier, because of the education is very costly, or so many people are not able to offer for the to gain the skills, and also the past historical methodology what they are still following, they have not changed the syllabus for so many years. It's a very big problem for the current generation, and they are not aware of the current technology. They will train based on the conventional machines, and once they have entered to the market, they will they may not able to get into the desired area, and even though they are entering, they may struggle to grasp the things. So intellectual property issue and adhesive in additive manufacturing. See, when it's coming to industry, the intellectual property issue, that means someone will invented something, so the industry will say this only belongs to me. So this is one of the biggest problem. Suppose someone has obtained a new design or invented something, if they started claiming, so all other industries will suffer, only one person can enjoy. This is one of the challenge. So certain designs or the inventions should be available for the entire world with a free of cost, where they can produce, because a one person can't serve the entire world. So on that basis, it has to be given certain amount of rights to the other industrialists or persons to carry out and produce the things. So growing complexities in globalization supply chain. See, suppose this is why means when you are manufacturing something, some countries are having a different taxations and import duties are different, and some countries may not allowing the certain productions which are produced by 3D printing or something because of the security reasons. So these are the things we have to keep in mind. So what are the components are allowed, not allowed, so we have to keep in mind. These are the very big problem actually. In certain countries they will for 1 rupee, if the cost of the product is 1 unit, the import duty will be 2 units, 3 units, 10 units. So that's how the supply chain will be difficult. Even though you are producing very good production and you are obtaining a cheaper cost, when you are supplying, you will have the problem. The promising future: advancement in artificial intelligence, increased in IoT intelligence manufacturing process, rise of decentralization of production models, strong forces of sustainable practices. See, when you see coming to advancement in artificial intelligence, yes, of course, because of the advancement in artificial intelligence, you can learn anything at a faster stage. So previously you have to search for certain amount of books. In the book, is that portion is covering a certain points or not. So that's also very important. But the advancement of AI will give you a very faster way of understanding the things. That means, suppose that how industry is running, which industry is good, which technology is good. Last year, how many members got job based on this. Suppose usually people will ask which software is best to learn. So all these things will be addressed in a fraction of a second. This will give you some thing to learn, even though you are far from the urban area, even though you are located at, if you are able to have an internet and how to access that one, if you are aware of that one, you can learn very easily. So increased IoT integration manufacturing process. See, the IoT, as I told earlier, even though they are not allowing the human interaction in the Internet of Things, in the certain cases, suppose someone who is residing at a rural area, he can work from home in the distance locations to support the manufacturing process, where he can procure the raw materials, or you can design, and you can 3D program can be done from the distance area, where the Internet of Things will come to picture and he can sustain. Rise of the decentralization of the production models. As I told, nowadays it is not a centralized one. Even you can produce in China, India, US, Germany, Japan, the data remains same. So what is that? You just feed the data to the machine, it will produce the component. So where it will reduce the import or export complexities. So if you are designing something and if you are sending some components, so the countries may have a difference of import export duty problems. It will be resolved. You can just send the program to that fellow. He will load the raw material, the design machining will be done, and he can obtain the product. So stronger forces of sustainable practices. So strong. So if you see, as we are repetitively learning and modifying our skills, which will enhance us to produce more and more, and it will make us to sustainable in the upcoming days. So these are the things for the day. So if you are having anything to discuss, so please let me know. So here so many, if you take some of the things here, if you are not able to understand, or if you are having any doubts, please let me know through your comments. And my idea is to just make you to think and understand. It's not like how much I know, I have just explaining and expressing that one in this way. So if you are having any doubts, or if you are looking for any other topics kind of things, because I'm thinking to move in such a way, one by one topics I will bringing in front of you. If you are able to understand, that's okay. Otherwise you just drop comments and I will answer for that one. So if you like this video, please do subscribe to my channel, like and share with especially with rural area people who are very much interested in material science, manufacturing and 3D CAD. So thanks for watching. Have a nice day.